Welcome back to the video series on integration and differential equations. Today we're going to do some review of the log rules. These three log rules come up in several different contexts within integration and differential equations, so we're going to do some review and a little bit of practice. The first rule is n times ln of a is equal to ln of a to the n. Let's call that the power rule. Second rule, if you've got ln of a plus ln of b, that's the same thing as ln of ab. Let's call that one the product rule. I think it's helpful to point out here that the product rule generalizes. So if you had ln of a plus ln of b plus ln of c, let's say, you could write that as ln of a single product. You'd have a, b, c inside the ln. And similarly, if you had a sum of any number of lns over on the left side, you could turn that into ln of a single product. And then finally, if you have ln of a minus ln of b, that's going to turn into ln of a quotient, ln of a over b, and we'll call that the quotient rule for ln. So the only restriction on these quantities here, the quantities that are going into the ln, a, b, c, those should all be positive quantities. Let's try an example to practice these rules. Let's simplify the following expression. We've got negative 7 times ln absolute value of x plus 3 ln absolute value x minus 2 minus 2 ln absolute value of 2x plus 1. Well, first thing let's do is we'll apply the power rule to each of these terms. So first term would become ln absolute value of x to the power negative 7. Similarly, our next term looks like this. That 3 in front becomes now an exponent on the absolute value. And then last term, I'm going to make it positive. We're going to bring the negative quantity here, the negative 2, right up into the exponent. So we're going to have plus ln of absolute value, 2x plus 1, to the exponent negative 2, rather. Great, so let's check. In each case we've brought the coefficient from in front of the ln, we've brought it into the exponent there, and if that coefficient was negative, then that results in the term now being positive once we bring that negative quantity into the exponent. So those are our power rules. We've now got a sum of a few different ln terms, so we're going to use the product rule, and in fact we're going to use the more general version of it. We know that if we're adding a few different lns together, we can create a single ln, and inside that ln, I'm going to give myself big brackets here, inside the ln we're going to have the product. So absolute value of x to the power negative 7 times absolute value of x minus 2 to the power positive 3 times absolute value 2x plus 1 to the power negative 2. Okay, so to continue cleaning this up, let's use our usual rules for negative exponents. So we'll keep any quantities with positive exponents on top. Any quantities with negative exponents will go down into the denominator, and their exponents are now becoming positive. So in the denominator, absolute value of x to the power positive 7, and that's multiplied by absolute value 2x plus 1 to the power positive 2. So very last thing we might do here to simplify this expression is notice that inside the ln, each of these factors here has an absolute value on it. And when that happens, instead of having these big square brackets outside the ln, we could actually just have one set of absolute values. So that simplifies it because we're able to drop some of the absolute values. It also lets the absolute values act as the brackets here so that we know that ln applies to everything inside here. So then we can write x minus 2 all cubed, and in the denominator x to the 7, no brackets required there, times 2x plus 1 squared. So there we have a more concise way of writing that original expression, now with only a single ln in the expression.